Hello, and welcome to Nexstara's video series on the Salesforce Developer Workbooks. In this track, we'll be walking you through the Apex Workbook. This video covers Chapter 2, Tutorial 9, Exception Handling. Exceptions are flags raised when errors or events disrupt the normal program flow. Throw statements are used to generate exceptions, while try, catch, and finally statements are used to gracefully recover from exceptions. Exceptions are more robust than error codes, asserts, or Boolean values because they bubble up from the source until they're caught by error handling code. Because of this, you don't need to write error handling code into every single method. Also, the finally statement allows for a place to recover from exceptions by deleting data, resetting variables, etc. In Salesforce, when an exception occurs, all DML operations are stopped and any previous changes are rolled back and not committed to the database. Then exceptions get logged to the debug log. If an exception is unhandled, Salesforce will send you a detailed email report with the exception. That's a brief description of exception handling. Now let's get started with the next tutorial. To begin, go ahead and log into your Salesforce Developer Sandbox. From the sandbox, go ahead and click on your name and open the developer console. I'm going to go ahead and open up an execute anonymous window. And use this for our examples. So the major pieces when talking about exception handling in Apex are try, catch, and finally. These are the statements that allow to actually perform exception handling in our code. The try statement allows us to encapsulate some code that has the potential for throwing exceptions. Following the try statement, we can have one or more catch statements. In this example, we have one that catches a DML exception, and then we have another one that catches just generic exceptions. This is helpful because you may want to have different operations for different kinds of exceptions. And then lastly, the finally statement allows us a place to clean up after all the exceptions have been handled. Now these concepts may seem rather simple, and at face value they are, but there are a few things to keep in mind. When using try statements and encapsulating some code for exception handling, keep in mind that you are changing the scope by encapsulating it in a try. Also, when you order your catch statements, always start from most specific and work back to most general. So now I'm going to show you some examples of some exceptions. First, I'm going to create a new S object and try to put it in the database. This is going to cause an exception, and I'll show you what that looks like. There we go. So we've got a DML exception, insert failed, because I'm missing required fields. All right, so let's go ahead. So that was an example of an unhandled exception. We have our code, did some operations, it threw an exception, and we didn't handle it properly. So Salesforce yelled at us. Now, go ahead and add some exception handling to this. Now we've got a try, doing the exact same thing, and we're catching DML exceptions, and we're going to write the result to the debug log if we get an exception. So go ahead and run this now. This time it worked successfully, and it's going to bring us to the log page for that statement. If we look at the debug log, there's our exception. The exact same thing we saw before. So even though Salesforce accepted that code and executed it, it looked successful, it really wasn't. It threw that exception, but we handled it. So there's an example of unhandled versus handled exceptions. So I'm going to go ahead and open our execute anonymous window again. And the next thing I'm going to illustrate is how statements within a try block get handled when an exception is thrown. So in our example, it's this line right here, insert M. that actually causes the exception to be thrown. Now, whenever you have a try block and it triggers an exception, everything after the statement that triggered the exception gets skipped and does not get executed. So I've gone ahead and inserted this right here to illustrate that point. So I'm going to go ahead and run this. It's going to make it to here. An exception is going to be thrown. The catch is going to get triggered, but this is going to be skipped. So we're only going to see this. It's going to look exactly like the last time we ran it. But I'm going to go ahead and just run that just to see what that looks like. So look here. Yeah, all we've got is our exception text. We do not have anything else, even though we added that additional statement. Now, that only pertains to statements within the try block. If I go ahead and take this out, move it down here, it will get executed because statements outside the try catch are not affected by handled exceptions. This would only get skipped in the event that something happened previously and an unhandled exception was thrown. So I'm going to go ahead and run that. This time we should see both messages in the debug log. And there we go. We've got our exception that we expect, and then we've got our extra debug statement we added. So that's how a try works. Lastly, we're going to talk about the finally block and how that works. For that, I'm going to use this example. So the finally block executes no matter what exception is thrown, and even if no exception is thrown. And we can see that in this example. So in this example, we're creating an XML stream writer. We're adding some XML to it. And then we're just doing some other generic operations here. We're creating a string variable s. And then right here, we'll throw an exception because we're trying to get the length of s and it hasn't been assigned a value. So we're just doing some generic operations up here, and then we're doing some other ones that are going to cause an exception to be thrown. Now, the reason this is a good example is if we had some kind of stream writer that we had open, when we were done doing the operations with it, we would want to close it. And hence, that's why we're using finally down here. So regardless of what happens up here, we're opening a stream writer, we're doing some things. Exception or no, we're going to want to close it when we're done. So it's going to do some XML operations, intentionally trigger an exception, and we're going to catch it right here. And then after it's caught, the finally block's going to run and close our stream writer. So let's go ahead and run this so you can see what I'm talking about. So here we go. We've got our exception. Attempt to dereference a null object, which is correct because we created a string named s with nothing in it, and so it's null, and then we tried to get the length of it. So that threw that exception. That was caught and reported appropriately. And then our stream writer was closed by our finally block. So that kind of illustrates the utility of the finally block. It's really nice, and when you need to perform operations that could possibly throw exceptions, but they need to be cleaned up after regardless, once you've started them, the finally block is really the statement for the job. So now that we've gone over the basic tools of exception handling, let's go ahead and take a look at some of the built-in exceptions and common methods supplied by the Force.com platform. We've already seen a few of these in our examples already. The one that we've already seen is the DML exception. So the DML exception is thrown when there's a problem with any DML statement, such as insert or update, statements like that. Another built-in exception is list exception. This is thrown when there's any problem with a list. I have an example of a list exception right here. So in this example, we're creating a list of integers. We're adding one value to it. And in this statement, we're reading the first element out of the list. And then in this statement, we're reading the second element out of the list, but it doesn't exist. So that's going to throw a list exception. So that's an example of a list exception. Null pointer exception. A null pointer exception is thrown when you attempt to reference something that has not been initialized or is null. So in this example, we're creating a new string, but we haven't given it a value. So by default, it's initialized to null, and then we're attempting to see if it contains the string ABC. But since it's never been given a value, it's going to throw a null pointer exception. The next built-in exception we're going to talk about is a query exception. Query exceptions have to do with DML queries that are run against the database. In this example, we've got this first statement where we're doing a select from the merchandise table where name equals X, Y, and Z. So this is going to return nothing, but we're taking the result of that and putting it into a list. Now, since this is going to return nothing, the list size will simply be 0. Now, this other statement is very similar down here. We're doing the exact same query. We're setting the limit to 1, so we'll only get one result. But since this is not going to return anything, and the result is not a list, but a single object, we're going to get a query exception. Because taking a query that doesn't return anything and trying to assign it directly to this object is going to cause a problem, because we'll get an uninitialized, this will wind up being uninitialized, basically. So that's how a query exception works. The last built-in exception I want to bring up is this S-object exception. So in this example, we're selecting name from the merchandise table with limit 1, and we're putting that into M. And then down here, we're trying to reference m.totalinventory, but we didn't retrieve that in our query, so it's not going to be accessible, and then it's going to throw an S-object exception. So S-object exceptions are thrown when dealing with S-objects. This is just an example of one instance that would throw one. So that's a brief introduction to built-in exceptions. Now, in addition to the built-in exceptions, there's also common methods for working with exceptions that are available. Here's an example of these. So here is our exception example from the previous explanation. And now in our catch, we've got a bunch of new stuff. We've got get type name, which returns the type of exception that is thrown. We've got get message, which we've used before, which gives the error message that's associated with the exception. We've got get cause, which returns the cause of the exception as an exception object. In this case, it's gonna return null. Get line number, which returns the line number where the exception was thrown. So that should be right here. That should be 5. And get stack trace, which returns the stack trace as a string, so we can see where exactly the exception came from. So I'm going to go ahead and run this just to give you an example of what all these common exception methods provide. Here we go. So the exception we've caught is an S-object exception, like we've talked about. S-object was retrieved via SOQL without querying the requested field, which we know that's why. The cause, we don't have a cause here. Line number is 5. And the stack trace, we've got an anonymous block, line 5, column 1. So that is a whole lot of information to know about your exception. It really helps to add that kind of stuff into your catch to help really pinpoint the causes of exceptions when they happen, especially kind of unexpected ones. Now, there's a couple more exception methods. These ones are specific to DML exceptions. So I'm going to use a different example to show you those. So in this example, we're going to be explaining the getDMLFields method. GetDMLFields returns the names of the fields that caused an error for specified failed record. DMLMessage, which returns the error message for the specified failed record. numDML, which that returns the number of failed records. So in this example, what we're doing is we're making a list of merchandise custom objects. One is completely intact, one is missing 2 of the required fields, and one is missing all of the required fields. And we're going to put them in a list, and then we're going to try to insert that list, and it is not going to work. And that's going to allow us to see all the DML errors from this example. So I'm going to go ahead and run this. Over in our debug log, we can see, okay, we've got 2 DML errors. In the first example, we're missing price and total inventory. And then here's the actual example. Required fields are missing, price, total inventory. And then as the second iteration of the loop, we'll see that it says we're missing description, price, and total inventory. It says required fields missing, description, price, total inventory. So those are some more exception methods specific to DML. But those and then the common exception methods really allow you to gain some insight when exceptions get thrown, so you can make sure all edge cases are properly dealt with in your code. Now that we're a little bit more familiar with the built-in exceptions and common methods for exception handling, let's do a few examples of how to catch different types of exceptions. So, the first example I'm going to do is an S-object exception from our previous example. So in this example, we're just catching a generic exception. Even though this is throwing an S-object exception, it still conforms to the parent object. So this will catch it, and then the get message will tell us that it's an S-object exception and what the nature of that exception is. So I'm going to go ahead and run that. And there we go. Tells us all about the exception and why it's a problem. But there may be cases where you want to do different behavior for different exceptions. And you would do that simply by layering in your catch statements. So in here we've got a DML exception, then an S-object exception, and then the generic exception. If we run that, we're going to get this debug output. So S-object exception caught. So that's what we expect, and that's kind of how it works. Like I mentioned previously, you want to start with more specific exceptions and then end with the more generic ones. The reason for that is that the code will stop as soon as it hits an applicable exception. So if I were to move this catch statement up earlier, here, like for example, if I put this exception here, even though it's an S-object exception and I've got an explicit catch for it, this is going to get triggered first. I'm actually just going to go ahead and get rid of that. So when I run this, I get an error where it says the exception type is already caught. So because this exception, the generic exception, came first, it caught the exception and that was going to be dealt with. But then it evaluated this exception, and since the exception already was caught, we now have an issue. So that's just an example of proper usage of catch blocks. Go ahead and put that all back. So if you want your catch blocks to behave properly and not get any errors, make sure you always go from the most specific to the most general. So I'm going to show one more example, and in this example, this is very similar to one of our other examples. Is we're going to create a new string named S, and we're not going to initialize it, and then we're going to try to do the contains method against it. So this is going to throw a null pointer exception. Now we've got several catches. We've got a catch for DML exception, a catch for S-object exception, and then the generic exception catch. So this is to illustrate the usefulness of the generic exception. If you're going to have exception handling and you're going to catch specific exceptions, you should also catch the generic exception so that if an exception comes up that you were not expecting, it will still be handled by your catch blocks. So I'm going to go ahead and run that. Even though we didn't have a specific catch block for an null pointer exception, we've got it. So now that we've laid a good foundation for exception handling, we're going to create some custom exceptions of our own. Now, the built-in exceptions in Apex can only be cut. You can't throw them because they're inherent to the structures provided by the platform. So we're going to go ahead and create some of our own exceptions to see how you could throw them. I'm going to go ahead and open this back up. Now, a custom exception just extends exception. So that's all you really need to create a basic exception. We can go ahead and create a new exception and specify a string here, and the string will represent the error message. We could also create a new exception and pass an object E, which would represent the cause of the error message in stack trace. And we can even go ahead and do both. Specify a string and an object responsible for the exception. So this is kind of a basic example of how you create and then throw your own exceptions. So now we're going to actually create a new exception. Show you how this works. From the developer console, we're going to go to File, New, Apex Class. And we're going to call this class Merchandise Exception. Now, the first thing we'll want to do is make sure that Merchandise Exception extends exception. And right now, we're just going to leave it empty like that. All right. Now we're going to use this exception class in the next class that we're going to create. The reason we're just going to leave these empty braces here is because we're just going to use the methods inherited from the parent exception class. Now we're going to go ahead and create another class. We're going to call this Merchandise Utility. Go ahead and add this code to the Merchandise Utility class. So all this class does is provide us with a couple public static methods. And so we're going to drill down and look at the insert merchandise method first. What this tries to do is it creates a new merchandise object and tries to insert it. And then if this catches a DML exception by trying to do this DML operation, it's going to throw a merchandise exception saying merchandise item could not be inserted, and then it's going to pass the DML exception into the merchandise exception, and then that's going to bubble up. So then if we look at this parent method, where we call insert merchandise and then catch merchandise exception, then we're going to see the message, the cause, the line number, and stack number by referencing our new exception we just made. So let's go ahead and save everything. And then I'm going to go ahead and put all this to work by calling merchandise utility main processing. And we're going to see the result of our new exception we made. Okay, so here's a whole bunch of stuff. Merchandise item could not be inserted. The cause is a DML exception, insert failed, which that is passed from the insert merchandise method. That catches this exception, then throws the merchandise exception and nests that inside. So that's where we get the cause from. So back in our debug logs, we know what the cause is. We've got the line number 22. Which is that. We've actually thrown the exception. and then the stack trace, which is class merchandise utility insert merchandise line 22 column 1. So we know exactly where it's coming from. Now, these are all the messages we explicitly wrote to the debug log. All these messages are messages generated by Salesforce in its handling of exceptions. So we caught it, we took care of it, but this is Salesforce telling us all the background regarding the exceptions that were thrown and caught. That's how you can create and throw your own exceptions in your own custom classes. It's basically just by extending the exception class, you can make your own exceptions and work them into your custom classes. So that's going to wrap up our video on Chapter 2, Tutorial 9, Exception Handling. In our next video, we'll cover Chapter 3, Tutorials 10 and 11, Apex and Context. Thank you for joining us. For more great content, click to subscribe to us on YouTube. Thank you.